Hi, welcome to the fun probability problem solving sections. And today we are going to solve another very classical probability problems here. So this one's here is that every mystery box includes a toy. There are 5 different types of the toy, and each box is equally likely to contain any given type. You buy one box each day. So first one's here, I want to find the mean number of the days which elapse between the acquisition of the third new toys and the fourth new type. Okay, so this type of the problem, like I say, is a very classical type of the problem, and so one of the very popular one is like in the old time, the cereal box. They always put like either like some coupon or like some little toys for the in the cereal box. So you need to find the toy at the end of it when you finish the cereal. So they have the different toys there. So this is the similar problem that how many boxes of the cereals you need to buy in order to collect all the toys here. All right. So now let's take a look. So what, how do we solve this type of the problems here? Let's go ahead and go to our whiteboards here. Okay, so before we do this, and the tools we need is the geometric distribution. Geometric distribution. So the geometric distribution, that means we will get the x minus 1 fail before we get a first success here. So what it looks like is like f of x is equal to 1 minus p x minus 1, and then this is the p. That means it's the probability we'll get x minus 1 fail till we get the first success, right? So the x could be 1, 2, and go to the infinity. This is we call this geometric distributions here. And one of the things we also need to know besides geometric distributions, right? We also need to know the expected value of the f of x is equal to what is equal to 1 over p. Those are the two things we're going to use when we try to solve these problems here. Okay, so now let's take a look. How do we set it up? All right. Okay, so now we know we have five toys, right? So here's the first one. So let's understand how it works, and then we'll be able to set up the equations here. So this is number 4, and this is number 5 here. All right. Okay, so think about it. Okay, so for the first ones here, so we said this is x1. That's the random variable code is x1. Okay, so here x2, x3, x4, x5 here. Okay, so for first ones here, you can find any one of the, you get any toys, right? So the probability here is going to be what? The probability here is 1. Is any one of them going to work? Okay, after you get this one, then you will get the second one. The second one could be, it's the different one, the first ones here, right? So it's the different one with the first ones here. So that means what you cannot do here, so you cannot, so that means you're going to have, so maybe it's, after you choose x1s, right, so you can have 1/5. I don't know how many 1/5 here is x, so right here, you finally get another one. So what is here? This is 4/5. So the probability of x2s here, this is obviously, this is a geometric random variables, right? So this is a geometric random variable with p equal to what? The p equal to 4/5. So it depends on x2 times before you try. The x2 times is the first time of success. Okay, after that, you get the third choice. So you already have the 2 choice chosen. So you could have many times before you get the third one. So it's 2/5 times 2/5 and times 2/5 all the way till you finally get a new ones here, right? So what is the new ones here? You can have 3 out of the 5. Correct? Okay, so now we know this one here is also is a geometry. It's the first success is 3/5, right? So P is 3/5. Okay, now for the fourth ones here. So after you get the third one, how long take it to get the fourth ones here? So after you get the third one, so you already have 3 out. So it's 3/5 times the 3/5 times the 3/5 and all the way till you get the fourth ones. So what is the fourth ones? You only left, you have 2 of the 5 to choose. So from the here, what is the is also is another geometrics. So what is the probability? Is 2/5. Okay, so now let's take a look at the last choice here. This will just be 4/5 times 4/5. So how many you got the previous one until you got the correct one, the last one. So it's 1/5. So I know this one here is geometrics with p equal to the 1/5 here. All right. Okay. So now the first questions they ask here. So what is the elapsed time after you get the third new type, right? So let's say after the third new type, how long will it take you to get a fourth, right? So that means after here, that's what basically we are looking for the expected value. After the third one, what is its fourth? Then based on the geometric expected value is 1/p, so it's 1/2/5, right? So that will be 5/2. So it's equal to 2.5 days, right? Or you can say it's about the 3 days between the third one. After you get the third one, it will take the 3 days before you get the fourth ones here. Okay, so now let's say how long will you expect to get the full set? All right, so to get the OR, so get the OR set toys here. Right, how long is that? So basically, it's just you do the expected value exp1 plus exp2 plus exp3 plus exp4 plus exp5, right? So this will be 1 plus what? 5/4 and plus 5/3 plus 5/2 and then plus 1/5/1 here. So it kind of get you some number is 11.42. So that means we know it's about 12 days. All right, so it's about 12 days you will be able to get all the 5 toys. Like I said, this is very, very classical probability problems, and it's very neat by using the geometric distribution. Okay, that's it. And I hope you enjoyed this problem solving here. Okay, bye-bye. Talk to you in our next ones here. Bye.